dear students. I am Mrs. Elaine Ruth A. Olaraza of Libertad National High School. In today's video lesson, we will learn about the equation of Boyle's law under the competency investigate the relationship between A. Volume and pressure at constant temperature of a gas, B. Volume and temperature at constant pressure of a gas, and C. Explains these relationships using kinetic molecular theory. Let us have a recall of Boyle's law. Boyle's law was formulated by Robert Boyle in 1662. Boyle's law describes the relationship between volume and pressure of gases at constant temperature. To understand the relationship between these two, watch the animation and observe what happens to the volume of a gas as the pressure increases. This animation shows a constant temperature reading of 300, pressure reading from 1 to 2, and volume from 1, 2, 3, 4, 5, and 6. Now, observe what happens to the volume of the gas as the pressure increases. Observe what happens to the volume reading as the pressure reading of the gas increases from 1 to 2. We can also show on the animation of the graph on the right that the higher the value of the pressure, the lower the value of the volume. Thus, as the pressure of the gas increases, the volume decreases. Let us watch again the animation, and this time, let us observe what happens to the volume of the gas as the pressure decreases. Again, the animation shows the constant temperature reading of 300, the pressure reading from 1 to 2, and the volume reading from numbers 1 to 6. But this time, observe what happens to the volume of the gas as the pressure decreases. You can also see from the animation of the graph on the right that the lower the value of the pressure, the higher the value of the volume. Thus, as the pressure of the gas decreases, its volume increases. So, how are the volume and pressure of the gas related to one another? Boyle's law states that the volume of the gas is inversely proportional to its pressure at constant temperature. How do you write this in mathematical equation? V is inversely proportional to P at constant T and N, where V is the volume of the gas, P is the pressure, T is the temperature, and N is the number of moles. The equation can be rewritten as the product of volume and pressure is constant. Considering the initial and final values of volume and pressure, we can have the equation V1 times P1 is constant and V2 times P2 is also equal to constant. Combining the two equations become V1 times P1 is equal to V2 times P2, where V1 is the initial volume of the gas, V2 is the final volume of the gas, P1 is the initial pressure of the gas, and P2 is the final pressure of the gas. This therefore means that the variable with a subscript of 1 is the initial value and the variable with a subscript of 2 is the final value. Let us consider the table on the effects of pressure on the volume of the gas. The values of the volume in liters are 6.0, 3.0, 2.0, 1.5, 1.2, and 1.0. The values of the pressure in atmosphere are 1, 2, 3, 4, 5, and 6. Now, getting the product of volume and pressure, 6 times 1 is equal to 6, 3 times 2 is equal to 6, 2 times 3 is equal to 6, 1.5 times 4 is equal to 6, 1.2 times 5 is equal to 6, 1.0 times 6 is equal to 6. This therefore shows that the product of volume and pressure is constant. Additionally, Table 6 on your Science-10 book, page 367, shows the data on volume-pressure relationship. We have trials 1, 2, 3, and 4. The values of volume in liters are 2.0, 4.0, 8.0, and 16.0. While the values of pressure in atmosphere are 10.0, 5.0, 2.50, and 1.25. We can say that as the volume increases, the pressure decreases. Let us derive the equation for Boyle's law. To show you how to derive the different equations, I will be needing a marker and a whiteboard. I also advise you to have your own paper and ball pen for you to derive the equations of your own. We are going to find out the value for V1. First, let us write Boyle's law equation. So the equation for Boyle's law is equal to V1 times P1 is equal to V2 times P2. So, to find for the value of V1, let us divide both sides of the equation by P1. Okay, divide it by P1 and also divide it by P1. In this case, we can now cancel out P1. So, our equation now for V1 is equal to V2 over P1 times V2. So this is now our equation for V1. V1 is equal to P2 over P1 times V2. Next, we are going to find for the value of V2. Again, we should write the equation for Boyle's law first. So, V1 times P1 is equal to V2 times P2. Since we are looking for the value of V2, let us divide both sides of the equation by P2. Okay, so in this case, we can now cancel out P2 on the right sides of the equation. Since we are looking for the value of V2, let us write the unknown on the left side of the equation. So, V2 is equal to P1 over P2 times V1. So, this is now our equation for V2. Next, we will find for the value of P1. We should write the equation for Boyle's law first.
V1 times P1 is equal to V2 times P2. Since we are looking for the value of P1, let us divide both sides of the equation by V1 to cancel it out. In this case, we can now cancel out V1 on the left side of the equation. So, our P1 is equal to V2 over V1 times P2. So, this is now our equation for P1. Let us derive the equation for the last variable, and that is P2. Again, we should write the equation for Boyle's law first. V1 times P1 is equal to V2 times P2. Since we are looking for the value of P2, let us divide both sides of the equation by V2. Okay, we can now cancel out V2 on the right side of the equation. Since we are looking for the value of P2, let us write the variable on the left side of the equation. So, P2 now is equal to V1 over V2 times P1. So, this is now our equation for P2. So, all in all, these are the derived equations for Boyle's law. The following are the units of volume: liter, milliliter, cubic meter, cubic decimeter, cubic centimeter, quart, and gallon. These are the units of pressure: Pascal, atmosphere, millimeters of mercury, centimeters of mercury, torr, and pounds per square inch. Lastly, these are the units of temperature: degree Celsius, degree Fahrenheit, and Kelvin. And now, the exciting part, the problem-solving exercises. Be ready now with your ball pen and your paper. Problem number 1. Oxygen gas inside a 1.5 liter gas tank has a pressure of 0.95 atmosphere. Provided that the temperature remains constant, how much pressure is needed to reduce its volume by 1/2? 1.5 liter is the initial volume, or V1. 0.95 atmosphere is the initial pressure, or P1. The final volume is 1/2 of 1.5 liter, which is 0.75 liter. The unknown is the final pressure, or P2. P2 is equal to V1 over V2 times P1. Let us substitute. V1 is 1.5 liter, V2 is 0.75 liter, and P1 is equal to 0.95 atmosphere. So, the final pressure is equal to 1.9 atmosphere. The volume decreases by half from 1.5 liter to 0.75 liter. And the pressure doubles from 0.95 atmosphere to 1.9 atmosphere. We have problem number 2. The inflated balloon that is slipped from the hand of Ren has a volume of 0.50 liter at sea level, 1.0 atmosphere, and it reached a height of approximately 8 kilometers, where the atmospheric pressure is approximately 0.33 atmosphere. Assuming that the temperature is constant, compute for the final volume of the balloon. 0.50 liter is the initial volume or V1, 1.0 atmosphere is the initial pressure or P1, and 0.33 atmosphere is the final pressure or P2. The unknown is the final volume or V2. The equation for V2 is equal to P1 over P2 times V1. Let us substitute. P1 is 1.0 atmosphere, P2 is 0.33 atmosphere, and V1 is 0.50 liter. The final volume is equal to 1.52 liter. We can see that the volume increases 3 times from 0.50 liter to 1.52 liter, while the pressure decreases by 1/3 from 1.0 atmosphere to 0.33 atmosphere. Finally, we have problem number 3. The initial pressure of a gas is 457 millimeters of mercury. The final volume is 750 milliliters with a final pressure of 650 millimeters of mercury. What is the initial volume of gas? 457 millimeters of mercury is the initial pressure or P1. 650 millimeters of mercury is the final pressure or P2, and 750 milliliters is the final volume or V2. Initial volume or V1 is unknown. The equation for V1 is equal to P2 over P1 times V2. Let us substitute. P2 is 650 millimeters of mercury, P1 is 457 millimeters of mercury, and V2 is 750 milliliters. The initial volume is equal to 1066.74 milliliters. The pressure increases from 457 millimeters of mercury to 650 millimeters of mercury, while the volume decreases from 1066.74 milliliters to 750 milliliters. It's now your turn to solve the following. Feel free to discuss your answers with me through phone call or messenger. Number 1. A 3.00 liters packet of air at sea level has a pressure of 100 atmospheres. Suppose the air packet rises in the atmosphere to a certain height and expands to a volume of 10.00 liters. What is the pressure of the air at a new volume? Number 2. A weather balloon has a volume of 1,750 liters at 103,000 Pascal. The balloon is released to the atmosphere. At the highest point above the ground, the pressure on the balloon is 35.0 kilopascal. What is the new volume of the balloon at this height? And number 3. A sample of fluorine gas occupies a volume of 600 milliliters at 760 torr. Given that the temperature remains the same, calculate the pressure required to reduce its volume by 1/3.